Hello everyone, I'm Typhoon, and in this lecture we will dive deep into how to use both the TShark and tcpdump to capture and analyze network traffic. We will start with TShark, exploring how to initiate packet captures and interpret the output. We will firstly open our terminal, and now we will enter TShark. So this command starts packet capturing in real time from the default network interface on your computer. TShark is the command line version of Wireshark, which is a packet analyzer tool. It captures data packets that are being transmitted over the network and displays them on this terminal screen. So how it works? TShark starts capturing all the network traffic on your system by default from the first network interface, in this case ENS33. In your case, it might be like ETH0 or VLAN 0. So let's actually decrease the font size so we can see more. And yeah, so um, in this output example, let's stop it. You can stop by Control C like this. And in this example here, we have, for example, in the first packet, this one here means this is the first packet in this capture session, second, third, fourth, and so on and so forth. And then we have the time. This is the time in seconds from the start of the capture to when this packet was captured. In this case, it was captured when it started, then in the 4 second, 19th second, 20th second, and so on. And here we have these IP addresses. This is the source and the destination IP addresses showing where the packets is coming from and where it is going. And we also have, in this case, it's UDP, for example, this, MDNS, SSDP, so on. So here, obviously, it says the protocol used by this packet. In this case, it is user datagram protocol. It is commonly used for web traffic. And here we have 86, 175, 93, 310, and so on. This means the length of the packet in bytes. So by looking at this number, you can see how much data is inside this packet. And here we have this. Here, this shows the port number used. For example, in this case, it's not a protocol, but yeah, that's it. And here, let's find something synchronization. In this case, I cannot see that in synchronization. So let's actually start the packet and visit some website. Hop, hop, hop. And here we have a lot of traffic going here. Let's stop it. And yeah, here you can see this is the port used in TCP. Here you can see that 443. This means this protocol is using SSL, which means HTTPS. And obviously you can see this HTTPS here. So it's connecting to this oxally.com. Here in this case, it's acknowledgement. This is the acknowledgement flag. This is the part of the TCP handshake. This is the one of the steps in TCP connections. Here in this example, I demonstrate how packets can capture as they travel through a network. Understanding the structure of this output is crucial because it tells you which application, you can see this identified by the port numbers, is communicating, the type of protocol used, and additional flags indicating the state of communication. Just like TShark, tcpdump captures packets from a network interface. So yeah, but we will not use this throughout our course, and it's pretty outdated. We can barely say it is updated here. And yeah, but this tool can be handy sometimes, but I prefer using TShark here. And here we are. Here we are seeing the timestamp indicating when the packet was captured. This is formatted as hours, minutes, seconds, and microseconds. This IP here, this packet is part of the IP protocol which is used to send the data over the network. And just like in the TShark, we have source and destination IP addresses or domains. And that's basically how tcpdump works. So let's go back to Wireshark or TShark. So in most systems, you have multiple network interfaces like Ethernet, Wi-Fi, VPNs, etc. By default, tools like TShark and tcpdump capture from the first available interface, but you may need to specify a particular one. In this case, let's TShark D, uppercase D. Here, this will list all available network interfaces on your machine. Here, this is the interface numbers used in subsequent commands to identifying interfaces. And this is the internal names assigned to the interfaces. And to ensure you are capturing from the correct network interface, especially when multiple interfaces are present, you can specify it explicitly. Like TShark E, in this case, ENS33, 1. Oops. TShark I and 1. By the way, this command will work same in the Windows as well. And here you see the capturing on ENS33. And here we are. Or you can also set the network interface name. So for example, sudo for the tcpdump. tcpdump I ENS33. And here, listening on ENS33. And here we are. So instead of flooding your terminal with packets, you can save them to a file for later analysis. This is especially useful when dealing with large amounts of data. For example, in TShark, you can do like this. Also let's set the destination here. Home, no, actually desktop. Wireshark captures. Wireshark captures and packets.pcap. Here you can see capturing on ENS33. You can see these are the bytes. Or if you go to YouTube, and here as you can see, it's as we spend more time, download more packets, use more internet, these bytes here will increase. Let's stop it. And that's it. We can also capture and save packets in tcpdump. sudo tcpdump I eth or ans33 w tcpdump tcpdump packets.pcap. And that's it. Let's stop it now. You can see 776 packets received by the filter. When you have saved the packets to PCAP file, here tcpdump packets, let's save it in the captures as well. You can later read and analyze them. In order to do that, we will use TShark R packets on, of course, it's on the desktop, packets.pcap. We have the typo here, TShark. And here we are. By the way, you can also open this in Wireshark as well. Close old project, click File, Open, Desktop, Wireshark Captures. Let's open the TCPdump. And here we are. We have captured this. Or we can also open recent or open packets.pcap. And here, these are the packets that we captured with TShark. And in this lecture, we have explored the powerful capabilities of TShark and tcpdump for capturing and analyzing network traffic. You learned how to initiate packet captures, specify network interfaces, and save captured data to PCAP files. And we also broke down some sample outputs to help you understand how to interpret packets details like IP addresses, ports, protocols, flags, and sequence numbers. So while TShark offers detailed packet analysis similar to Wireshark's graphical user interface, which is best, I prefer using TShark in my analysis, but tcpdump is lightweight and is good for quick captures in command line environments. So both tools are essential for network troubleshooting, security analysis, and understanding the flow of data across networks. So mastering these tools will not only enhance your skills in packet analysis, but also prepare you for more advanced network security tasks. I'm Typhoon, and I'm waiting you in next lecture.